Bismillahirrahmanirrahim. Assalamu alaikum. My name is Khalil Burhani, and today I will present you a topic which is the connection between Shear matrix and eigenvector. To understand this topic, you should be familiar with the identity matrix, Shear transformation, and eigenvector and eigenvalue. These are the example of the identity matrix, which is very simple and you understand it. Shear matrix is actually an elementary matrix that represents the addition of multiple of one row or column to another. Such matrix may be derived by taking the identity matrix and replacing one of the zero element with a non-zero value. We will see the example. These are the example of the shear matrix. This is actually an identity matrix. Only the 1 0 is replaced with this value. All this value are replaced with all zero, any zero replaced by this value. Shear transformation, actually the name shear reflects the fact that the metric represents the shear transformation. If we consider it geometrically, such a transformation takes pairs of points in a linear space that are purely axially separated along the axis, whose row in the matrix contains the shear elements and effectively replaces those pairs by pairs whose separation is no longer purely axial but has two vector components. Thus, the shear axis is always the eigenvector of the shear matrix. Eigenvalue and eigenvector. Here you will understand the eigenvalue and eigenvector. If you consider delta as an eigenvalue of matrix A, and if there exists a non-zero vector which is x such that ax equal to delta x, in this case vector x is called an eigenvector of corresponding to this value, which is the eigenvalue. You should understand that this is for all matrices. But for the shear matrix is different, because for the shear matrix the eigenvalue is only 1, and that's why every and each non-zero vector, if you take, it will produce or it will satisfy this equation. And that's why for the shear matrix you can take any vector. And also for the general form for finding the eigenvectors corresponding to the shear axis is as follows. You can see here it shows the x shear, which can be derived the eigenvector like this. This is the point for the eigenvector. It can be, it's the equation to find the eigenvector corresponding to the x shear, and also this is the equation to find the eigenvector corresponding to the y shear. This is one example that's showing the eigenvector, which is getting or obtaining from the shear matrix an arbitrary vector, and this is the 7 and 4, and actually these are between this vector and this vector there is a relationship, because for we say that it is x shear, the y doesn't change, the y coordinate doesn't change, but the x will be changed. How it will be changed? This will be the x coordinate plus the shear element times 4. 1 times 4 plus 3 is 7. And now it is, you can see the graph here. This is the arbitrary vector, this is 3 4, and this is the shear vector, which has been produced by this shear matrix multiply this arbitrary vector. This is an x shear. You can see the vector shear toward the x. Example 2 is the y shear. You see the x coordinate doesn't change, but the y coordinate is changing, and the vector is changing or shearing toward the y. You can see here this is the shear element, and this shear element can be times 3 plus 4 is the y coordinate, which is 7, and the x coordinate will be not changed, and it is 3, 7. This is the eigenvector of this Shear matrix. We can find many eigenvector from different vector that we take, because the eigenvalue for Shear matrix is 1. That's why we can find many eigenvector by taking arbitrary vectors that can be times by the Shear matrix. So this was some idea and example about connection between Shear matrix and the eigenvector. Hope you understand. Thank you for watching.